They don't know how to do question 7. Do I need to go over question 7? Huh? You should get -1 over 16. Is that what you got? Okay, good. Then we have go over. Is that okay?
Yeah.
The reason why that question is not a very fair question is because the hold on a second. I'm gonna have to share my screen. So okay, so let's talk about this question. So is the limits as x approach 0, 1 over x plus 4, 1 over 4, all over x. Now, before this, I want to go over the test questions. And I think this is a test question, and I know that everybody did it in a different way, and I will say I don't prefer that way, so I'm gonna explain you why now. So 9x to the -1 minus 36y to the -2. A lot of people did difference of a square on this particular question. It's fun. It worked for this question, but it doesn't always work. So I'm going to show you one way is always going to work if you ever simplify this fraction. This is called a complex fraction. And then since x to the -1 power, that's only applied to x. So actually 3 over x, that will be the easiest way to think about it. This one's 6 over y over 9 over x minus 36 over y squared. So also another thing you need to understand, there is a parenthesis, invisible parenthesis top and bottom. That's going to tell you what's the order operation, because even though it's not there, but it's still there. So what you're going to do is going to multiply this by adding those two together by common denominator. So y over y. So this basically is a 4th grade math. And this is y squared over y squared, x squared over x squared. Now, yes, if you see this 4th grade, you're going to never do math again. But this is a high school algebra 2 problem. And then you say, okay, that just combine the top. That's going to be x, y, 3y minus 6x. And on the bottom, it's going to be 9y squared minus 36x squared over x squared, y squared. Now, if you do it this way, always going to get the right answer, regardless what kind of question it is. Because if you do a difference of a square, that doesn't always work. Now, this divided by this, right? Remember a long time ago, you learned 3 divided by 5 is 3 divided by 5. How about 3 over 2 divided by 5 over 4? That's going to be 3 over 2 divided by 5 over 4. So can I just do it backwards? Let's go backward here. And then can I just write down 3y minus 6x over xy divided by x squared, y squared over 9y squared minus 36x squared. Does anybody lost? Everything's okay? Yes.
Question.
Go ahead.
Why would you multiply the bottom by x squared?
Because the common, oh, this one's an x squared, yeah.
I seen the problem he meant to write x to negative second.
Yeah, x to negative second. And then I will have 3y minus 6x over xy, thank you, times by 3y minus 6x and 3y plus 6x. And then I will have, I divided wrong. So this one should be divided by the other way. So it's divided by 9y squared minus 36x squared over x squared y squared. And then this part is gonna be flipped to the top over 9y squared minus, well, that can be factorable. So it'll be 3y minus 6x and 3y plus 6x. And then this will cancel out, this will cancel out, this will cancel out. It will actually end up with xy over 3y plus 6x. Now, what's similarity between this question and this question? Well, just combine the top. How do we combine the top? Times x plus 4 on the right side, right? Does that make sense? So just apply the same math and apply this by 4 over 4. Then I will get 4 to the x plus 4 over, now this is where to make mistake, 4 minus x plus 4. A lot of you guys don't distribute this negative sign because you forgot to write a parenthesis here, and then you won't distribute. So keep a parenthesis when you're multiplying, and that way to make sure you're not make a mistake. Any questions here? Now 4 minus on the top, limit x approach 0, 4 minus x minus 4 all over 4 times x plus 4, and then it's divided by x. So that's times 1 over x, right? If divided by x, is that times 1 over x? So this 4 cancel out. Negative x over 4 times x plus 4 times 1 over x. This will cancel out. That's negative 1, 4, x plus 4 is equal to negative 1 over 16. So that is the final answer here. And that is the things that you want to get to. Now this is called complex fraction. If you have complex fraction, and that's why I give you this homework very beginning. If you ever do that, you ever to do this one. The only thing is people forgot to distribute this, so pay attention. People forgot to distribute this negative sign. In your homework, you're gonna forget too. And that's why you get negative 1 over 16 instead of 1 over 16. Is it okay? Okay. So let's go back here. Let's look at this big picture that we did. We finished factor and cancel. We finished radical and conjugate. And we finished combined fraction. The last question is what? Absolute value. I would say this is the hardest one to understand. And this is something that I thought my student hopefully will do a better job than any other student out there, is because I understand the absolute value. Because I'm going to spend some time on it. I'm going to go back to teach Algebra 2 correctly. Algebra 2, we mentioned absolute value x. But we never mentioned, by the way, absolute value x is actually pretty interesting. Do you guys know this? You see the x squared graph look like this, right? And do you see that square root of x graph look like this? Right? What if you combine both graphs? What if the square root of x squared graph? What does that look like? What if I put a square over there? What do you think it's going to look like? Square root x squared graph look like what? Yes, Emil? We show you two graphs there. The blue line is square root x. the x squared is a problem. But what is square root of x squared?
Wouldn't it make one positive and one negative?
Will be a linear?
Two, because
Huh. Let's see if it's true. Ready? It's not linear. It's an absolute value graph.
well, isn't it just the two and then you get rid of the overlap, like the do the vertical line test?
Well, no. Well, here's the thing. The absolute value x is actually has another definition. Square root x squared is actually absolute value x. A lot of people didn't know this. But is that what you expected? Yes? No, right? I don't think so. But that's good. At least now you know. Okay, absolute value x. Obviously, absolute value x has a graph that look like this. And what I will say is this one is x. And there's a blue part of the graph. This is a negative x. So f of x, oops, f of x equal to absolute value x can be rewritten as f of x in terms of piecewise function. And that means x when x greater than 0 and negative x when x is less than 0. So there are two functions. The one on the right is x, the one on the left is negative x. Why is that important? We're going to see in a second. Because a lot of people don't know how to deal with absolute value. This is how you deal with it. This is called definition of absolute value. So if you guys don't know, this is called definition of absolute value. Nobody ever mentioned it in Algebra 2 because nobody see the needs of it, but it's very important for the high level math. Now, what happened if f of x equal to absolute value x plus 2? What does a graph do? Moving which direction? To the what? Left, good. If you say left, that means you understand transformation. Mr. Chabral does a really good job. This is x plus 2. See, there's a positive version of this graph. And this is the negative version of this graph. So in this case, f of x is equal to what? X plus 2. When x greater than 2, negative 2, sorry. And negative of x plus 2 when x is less than negative 2. So I just rewrite a equation to two pieces. And those two pieces matter. Because my next question is going to say, hey, do you know what this graph look like? Do you guys know what does absolute value x minus 2 over x minus 2 graph look like? Anybody have a suggestion? Should I hold my breath? If I die, it's all your fault.
The line negative x minus 2 with a hole at x equals 2.
It's going to be two horizontal lines, one at x equals or y equals 2, and one at y equals -2. Or not those values, but it's going to be two horizontal, one to plus, one to negative.
Which value?
One. One and negative one.
1 and -1. Thank you. The reason why the graph will look like this is because if you pay attention, right? Can I write this in piecewise? Yes, right? F of x in term of piecewise, this will becomes the positive version is going to be x minus 2, right? Over x minus 2. Why that's a black? And the other side we're going to write in green would be negative of x minus 2 over x minus 2. And this algebraically, you see it when x is greater than, sorry, this one is when x is greater than 2. And this one is when x is less than 2. Right? I replace that, the top, with the positive version and negative version. Now what happened is this will eventually cancel out equal to 1, right? And this will eventually cancel out equal to -1. Does that make sense? So on the left side of 2, no longer have, on the left side of 2, so 1, 2, on left side of 2, on right side of 2 is going to be a open circle at 1, going this way, and this blue circle is going this way. And that will be a graph. Is that pretty interesting? Not like what you expected, right? Yes.
How did you get the 2 for the x greater than 2 and x equals 2?
Because I know my transformation is moving to the right. So right 2 units. So it has to be greater than 2. On the right side, it's going to be greater than 2. On the left side, it's going to be less than 2. Yeah. Because that's numerator is absolute value x minus 2. How many of you guys are confused? Like I said, it's not easy to understand absolute value. There's so many tricks in there that you don't see. Now, the next thing is going to be, what if I have limit x approach to, I don't know, 2 from the left, right? It's a semi-equation. So absolute value x minus 2 over x minus 2. If it's 2 from the left, you're going to plug in the blue one. And if you do limit x approach 0, this is going to become -1. If it's 2 to the left. If I do 2 to the right, on the positive side, then you're going to do x minus 2 over x minus 2. That's going to be the red part. And that's going to be x minus 2 over x minus 2. This will cancel up to be -1. Therefore, as the limits, x approach to 2 of absolute value x minus 2 over x minus 2 equal to does not exist. It actually cannot define. Sorry, this one's a -1. Why it does not define? Because just say if me and Emil, we're trying to search for this black hole, and Emil coming from the right side says, well, I know I detect the black hole at x equal to +1. and I approach from the left side, I say it's -1. Now the thing is inconclusive. It's not for sure a same value. So we're gonna say that therefore this limit does not exist. If you approach it from the left, equal to one value. If you approach it right, if you equal to another value, that does not exist. Does that make sense? If they equal the same value, it does exist. So let's talk about when the limit exists. Limit exists when x approach to a is a some type of constant of f of x equal to limit as x approaches a from the right of f of x. This one limit exists. Now what if it's approach to the left does not equal to limit x approach to the right? Limit does not exist. Does not exist. It's fairly straightforward. Left has to equal to right, approaching. If approaching different number, it does not exist. Is that okay? That's what the limit's about. The left side and right side, if me and my Emil says one says -1, we cannot conclude that there's a one single black hole. There are probably two black holes, but we cannot define that. Define means you know exactly where it is.
The difference between
The first second one just does not equal to. See, that does not equal to, and this is equal to. It's pretty easy. Are we okay here? And you guys gonna try and question. How about limits? And knowing when to use which equation, right? So let's just say 3 from the left of x, absolute value of x minus 3 over x squared minus 9. Are you okay? What'd you get? Nobody can tell me answer.
-1.6.
Did everybody get it right? That's nice. I got it right. It's -1.6. Emil says, I don't know. How about everybody else? See, this is the left side, right? If it's the left side, you're gonna plug in from the left side equation. So that's equal to limit x approach 3 from the left side. That's gonna be negative x minus 3 over x plus 3 and x minus 3. And this will cancel out. It'll be -1 over x plus 3. Limit x approach 3 from the left. So it'll be -1 over 6 if I plug in 3. Questions? Okay. How much time I have? How much? 16 minutes?
15.
Oh, 15 minutes. Okay. I don't want to continue this teaching because that way this class is going to be ahead, another class will be behind. So I'm just gonna write down the homework question that you guys gonna have. So part 2. So the first question is gonna be easy. Limit x approach 0 of x squared plus 3x over x. Second question is limit x approach to -1. Nope. -2, 3x squared plus 5x minus 2 over x plus 2. The third question is limit x approach to so it's 27x cubed minus 64 over 4 minus 3x 4 over 3 4 What is it?
Root 4 is like 8 minus 6.
5 minus 6. That's 2. Yeah, they are trained to be able to read my messy handwriting. What is that again? It's gonna be like 30 messages in a group chat. You don't have to write down the problem, just do one problem at a time. I'll post on the group chat.
Yeah, a little dot. Yeah, bottom. That's how you know.
What happened?
You're 64. That's